Hello and happy Wednesday. This is Learn It, Give a Sequence, Find a Rule. You've been doing sequences usually since kindergarten or first grade. So they would go red, blue, red, blue, red, blue, and then you would say red. Or you would say 2, 4, 6, 8, and then they would say what comes next, and you would say 10. So you've been doing sequences for a while. This is going to formally do it with numbers, and you are going to be able to come up with a rule so you don't have to draw the entire thing out. So if I asked you what the 256th term is, you wouldn't have to keep drawing a table. So a sequence is a list of quantities such as objects, figures, or numbers where order is important and the next number is predictable. So right here it says 7, 12, 17, 22. Can you predict the next number? Well, if I go from here to here, I add 5, and from here to here, I add 5, and from here to here, I add 5. So the next number is 27. That's called an arithmetic sequence. For arithmetic sequences, I can have it as a list. I can do 5 representations. I can do a table. I can do ordered pairs. I can make up a situation for this. I can make up a rule. And I can make up a list of numbers. Okay? When you are given 1, you can create the other 4. So all I need is this, and then I can make all of these. And I'm going to go through a couple with them. So here we go. Given this, let's create some of the other representations. So from a table, okay, so you have the list. This is first position, second position, third position, fourth position. Okay, your first position, when I have the first position, gives me 7. The second position gives me 12. The third position gives me 17. The fourth number is 22. So I'm actually going to list them, and instead of putting the position numbers on the bottom, I'm going to put the position numbers on the top. Therefore, conveniently, these are my X's and these are my Y's. Okay, X is always input, Y is always output, N is the nth term. So the first term, the second term, the nth term. You can create ordered pairs. So this could be 1, 7, 2, 12, 3, 17, and 4, 22. Okay. From ordered pairs, you can graph. So if I have a graph, I could come over 1 and go up to 7, 2 and up to 12, and 3 is 17. And you notice that on arithmetic sequences, they're going to create a line. And you can predict the next value. What did you do? Okay, so right here, up at the very top, we said we added 5. Added 5 each time. So the reason we need the rule is because if you ask for the 15th term, I would not want you to spend the time going 5, 6, 7, 8, 9, 10. And we're going to learn how to create the rule in a bit. So, again, a sequence is a list of quantities such as objects, figures, or numbers where order is important and the next number is predictable. Okay, on this one, we're given the rule and we're told to find the first term. So we're going to do 1. And I'm going to, here you're given a rule and asked to create a table. So you're going to use some spot over here and you're going to go, when I plug in a 1, I know 3 times 1 minus 2, which is 3 minus 2, which is 1. So if I plug in a 1, if I input a 1, I output a 1. If I input a 2, 3 times 2 minus 2, 6 minus 2, which is 4. Okay. And then I'm going to do 3 times 3 minus 2, and I'm going to get 9 minus 2, which is 7. So when I input a 3, I get 7. And then I'm going to do 4. 3 times 4 minus 2. And I'm going to get 12 minus 2, which is 10. So when I input a 4, I output a 10. And 3 times 5 minus 2, 15 minus 2, which is 13. And I'm going to do 5 gives me 13. So I'm going to show you a couple of things from the table that we might notice. If I go from here to here, I'm adding 3. If I'm going here, I'm adding 3. If I'm going here, I'm adding 3. If I'm going here, I'm adding 3. This, although it's adding, is my multiplier. Okay. The next thing, I can go 13, 10, 7, 4, 1. I can subtract 3. Okay. If I gave you 5, 4, 3, 2, 1, I could create a 0 right there. And if I did 13, 10, 7, 4, 1, I'm adding 3 to go down the column. I can subtract 3, and I get a negative 2. And this guy right here corresponds to that guy right there. From ordered pairs, you can make a list, right? Set notation. 1, 1, 2, 4, 3, 7, 4, 10, 5, 13. You can go on, but this is the set. Okay? You create ordered pairs, you could create a list. Okay? Now we're going to figure out how we can do the formula, writing the formula for the nth term when given a sequence. So I'm doing 2, 6, 10, 14. Okay, first of all, I'm going to put my terms first position, second position, third position, fourth position. Okay, I'm going to do 1, 2, 3, 4. And when I input any x, I'm going to get a rule. My my output is 2, 6, 10, and 14. So explain in words how y changed. Well, from here to here, I added 4. Here to here, I add 4. And here to here, I add 4. So, add 4. In words, how did x change? 1, add 1, add 1, add 1. When I have this, and I say finding out how y changes and how x changes, it's called calculating the rate of change. So if I wanted rate of change, I would say the change of y over the change of x. And the change of y was 4, and the change of x is 1. So that would be my rate of change. Now we're going to create a rule. Multiply the constant rate of change by 1. So we're going to do 4 times 1, which is 4. And then we're going to look at in the 1 spot, is that a 4? And it is not. So, did it give you? No. So then how far away from the value are you? Well, you're at 4 and you've got to back up to 2. So we're going to back up 2. So I'm going to subtract 2, which means subtract 2. So what I did is I multiplied my number by 4 and then backed up 2 to get y. So this says to get y, I take my number, I multiply by 4, and then I back up 2 to land here. Now we're going to check if it works for everybody. So we're going to go 4 times 2 minus 2. So when I input 2, 8 minus 2, I get 6. I did get 6. And then I'm going to check the next one. and do 4 times 3 minus 2. 12 minus 2 is 10. When I inputted 3, I did get 10. And then I'm going to do 4 times 4 minus 2. 16 minus 2 is 14. So it works. I'm going to do one more thing, and I'm going to back up, and I'm going to say 4, 3, 2, 1, 0, and I'm going to do 14, 10, 6, 2, and if I subtracted, I would get negative 2, and when the value is 0, this is the backup dude. Okay? Now, if I asked you to find the 51st one before finding the rule, you'd have to be listing it and never make a mistake for a long time. Now to find the 51st, I do 4 times 51 minus 2. 4 times 51, 4 times 50 is 200, minus 4 is 1. Plus 4. 204 minus 2, which is 202, which is 202. We're going to do this process for almost the entire unit. Okay, here we go. We did it once, we're going to do it again. So, from a table can create ordered pairs. So, first of all, I have to put my positions. 1, 2, 3, 4, and these are sequences. In sequences, you have positions, and they're called nth terms. When I input 1, I get 3. When I input 2, I get 5. When I input 3, I get 7. When I input 4, I get 9. So I have a set of ordered pairs. And I have 1, 3, and then 2, 5. And these are the 5 representations. We're going to go through a couple of them. 3, 7, and 4, 9. From ordered pairs, I could graph. And I could graph and go 1 over 3 up, 2 over 5 up, 3 over 7 up, 4 right, 9. And it's going to create a line, and sequences do create lines. So now we're going to predict the next values in the x and the y. We're always going to start with the prediction of the y. So from here to here, that's plus 2. From here to here, that's plus 2. From here to here, that's plus 2. So add 2. And then this is plus 1, and plus 1, and plus 1. And then how y changes is called the calculating of rate of change. Oh, add 1. And what we're going to do is we're going to say change of y over the change of x, which is 2 over 1, which is 2. Okay? So my rate of change is 2. Now we're going to create the rule. Multiply the constant rate of change, which we found is 2, and multiply it by 1. So we go 2 times 1, and that's 2. But we're not, when we input 1, do we land at 2? No, we land at 3. So that's a no. So how do we get to 3? We add 1. So then this is 2x plus 1 gives me my y. So y equals 2x plus 1 is your rule. Take any number, multiply it by 2, add 1. Okay? So here we go. We're going to do something in the table. 4, 3, 2, 1, 0. 9, 7, 5, 3, that would be 1. This matches that. Always. Use the rule to find the 43rd. 2 times 43 plus 1. 43 is 86 plus 1, so it's 87. And I would not want you to spend the whole day making a table to get to 87. We can do sequences with pictures. So